So my name is PJ Waskovich. I'm going to be talking about the sovereign cloud today. And when we talk about sovereign cloud, there's a couple of different meanings. So I'm going to specifically be focusing on a couple of trust and control and cost issues around sovereign cloud, rather than covering all the legislative issues as well. But we'll briefly cover some of the landscape in 2026 of how legislation is going to change things towards the sovereign cloud. But starting off with, I want to go through a very brief introduction, but I have a lot of slides to go through, and I really want to dive deep into some of the concepts, and those concepts really covering where the benefits of sovereign cloud are, the blueprints for moving towards sovereign cloud, and some of the risks as well that are encompassed in moving to the sovereign cloud as well. So I want to cover briefly who I am and why I'm giving this talk as opposed to other people, and where my experience comes from in this, because it is a fairly new concept. So having any depth of knowledge in this area is very, very slim at the moment. So this is a subject we'll go through. The itinerary has been shared before, but I just want to go over what you can expect from this talk as well. So at the moment, we're going to be covering what is a sovereign cloud, at least from my perception, but there's a lot of different views at the moment as well. And there's a lot of, I would say, marketing and PR in this space as well. That's worth understanding, especially from the main cloud providers in the US, who are very much embattled in this space due to legislature. Then I want to cover why sovereignty is more cost effective, because most people seem to think that moving towards sovereignty is not cost effective, or if it is cost effective, they are confused about the mechanisms by which they can recoup some of the costs by making those migrations. So I want to go over that as well. The differences between some of the sovereign cloud blueprints, I'm really going to go high level there, but I can go through more in-depth questions later as well. So feel free to come back with some questions around some of the blueprints. And obviously beyond this talk, I'm happy to dive deeper into specific solutions and how those blueprints apply. And then I want to look at the transformation. So how you do a transformation project towards a sovereign cloud, and how that looks in a very risk-averse and cost-effective manner. And then effectively how you build a future-proofing cloud strategy now towards the sovereign cloud, or at least enabling the sovereign cloud without it being a risky proposition for your organization. Organizations obviously differ in size as well. So not everything fits every organization, but I've certainly applied this for startups all the way through to large global cloud companies. So the blueprints do differ, but the premises are effectively the same. So why am I doing this talk? I've had 2 decades of building global scale systems, including for Microsoft and Amazon. So I'm very much aware of how to build those systems effectively. And again, I've worked with startups as well. So I've worked on more small scale solutions. I've had 2 decades of AI development, which is a rarity. And applying that in a cloud environment is very specific. I'm not covering the AI scaling in sovereign cloud infrastructure in this talk, but I am happy to go into those details or answer any questions after that. Again, the same principles apply. It's slightly more complicated with AI workloads, but you can still do it. I've generated in the first 15 years of my career about 1.5 billion euros in first year return on investment. So that differs massively between the projects I've worked on, but it's a significant amount. So I know how to reduce those costs in going to different cloud strategies. And a couple of the companies I've worked with that are very relevant in this space are Amazon, who I've worked with their GPU architecture, ARM, who I've worked with their developer tooling, Audi, Google, Microsoft, NVIDIA, a lot of AI work I've done in those spaces, and then Porsche and Sony for consumer productization as well. So let's start off with the sovereign cloud. At the moment, when we talk about sovereign in this talk, we're mostly focused on the European landscape, because that's what most people mean by sovereignty. It doesn't necessarily mean that, but most of us are working with the big 4 US providers. And when I say big 4, a lot of people think there's only a big 3, but IBM has a significant market share globally, even if it's not so much in Europe as well. So they are all relevant in this space. But most of us use them, and most of us use them because they're cost effective to get started. You get some startup funds, for example, or some other grant funding, and you can get up and running quite easily because they have some very, very simplistic tools to get started, and then more complicated tools as you try and scale. And then there are 3 major Chinese providers. There are more Chinese providers than this, but these are the main ones. So Alibaba, Huawei, and Tencent. Now, Huawei is a confusing one because people don't think of them as a cloud company, but they own 18% of the Chinese market, so they are significant. So understanding their cloud offering is worthwhile as well. And then there are obviously hundreds of mid-sized providers like DigitalOcean. All of these predominantly are US side. So I want to cover that there are good European providers out there that are far more cost effective to work with and have some great tooling as well. So what is the sovereign cloud? I'm going to go through two different concepts here, the technical sovereign cloud and the conceptual sovereign cloud. So technically, it's geographically local cloud services. That could be judicial local. When we talk about geography, for example, we could say European, we could say Danish, we could say Swedish, but it's geographically local, however way you read that. And it's the same for data storage as well. You can look at both. And then data and traffic tends not to travel in the sovereign cloud. The idea is it stays within its judicial region, or specifically the technical region which you build out. And then data protection compliance, it tends to be automatic. And there's a big asterisk there because it's not really automatic. Data protection still requires some work, but a lot of the work is done for you by just keeping your sovereignty within a certain cloud provider. And the US providers are moving towards sovereignty in Europe as well, because they realize at this stage they have to in order to provide compliant solutions for companies using their services. But we're not just talking about compliance here. We're talking about cost-effective development as well, and flexibility and freedom to choose tooling. And if you look at the Chinese providers, all of their cloud services are sovereign. So anybody that's operating in China, it's a sovereign solution. You're not allowed to operate foreign cloud systems in China. So if you have, for example, Microsoft Azure operating in China, it's because it's a Chinese company operating a Microsoft Azure stack and rebranding or white labeling. But there are no foreign cloud providers in China at this stage. And the European model is effectively trying to create a similar idea, but with more flexible and freedom for foreign companies to operate within a certain set of guidelines. This also means that if you do want to operate in China, you have to use a Chinese provider, which is worth considering if you want to access a huge market share as well. So conceptually, when I talk about the sovereign cloud, I mean these three things. I mean control, ownership, and trust. And I mean trust in terms of what you've built. You trust what you've built to always be functional and operational because you understand the stack a little bit more. You have full control ownership. You know, things aren't going to change overnight and then something doesn't work. And you can control it in terms of where things are positioned, what kind of computation you're using, even controlling the budget, because you have transparency over everything you're doing within that sovereignty. But that's kind of the layer system of what sovereignty is with the cloud. We have a very technical judicial process, and then we have the conceptual process of what a sovereign cloud is and what you're trying to get out of that. And it could be what I term a self-sovereign cloud, where you own everything. Maybe it's on-premise, for example, or a general concept of a sovereign cloud, which is maybe the European cloud. So let's go into costs straight away first before we go to the technical things, because I want to cover some of the mythology and some of the practicality between what is cost effective with the sovereign cloud. So most cloud operators currently, traditional cloud operators, and when I mean traditional, I mean the US model of cloud operation, which is fairly complex, are based on a tier model. So they price according to control and convenience. So how convenient is it to deploy something to their cloud, and how much control do you have over that? So if you go for bare metal, which most people don't, you have a lot of control. It's not very convenient, but it's very cost effective as well, because you have to do a lot of work really to make that work. You may be undersubscribed in there, meaning you're not using as much of the computation that is available, but it's very cost effective for what is available. And then we have the VPC. So this could be virtual private servers as well, virtual personal computers, but I call them virtual private compute. So it's a compute that you own that runs on a cloud provider, but it's not full bare metal. But again, you're doing a lot of work in there. You may be installing your own Linux distribution. You may be installing your own container runtime. You have a lot of control over that, and you get that cost effectively compared to other solutions because you have that control. And then we have unmanaged. So when I say unmanaged, mostly around containerization. I'm going to go beyond containerization in a little bit because I think there's more interesting things that are available now than containers. But we have unmanaged containers. So they're the containers where you deploy them yourself, you manage the orchestration yourself. It could be that you've just installed Containerd or Docker on a VPC and you're managing that yourself. Or it could be you have your own container distribution orchestration system like Kubernetes running rather than a managed version of Kubernetes. And then managed. So managed is when people are using Kubernetes. With most cloud providers, they use managed. So that could be Google Kubernetes Engine, for example, or AKS on Azure. So that provides a lot of benefits over the complexity. You have a great solution there, but you then tend to have higher costs because even though your cost of running containers might be moderatively low, you then are paying for additional auxiliary services on top of that, which you only find out when the bill comes at the end of the month, unless you're really diligent in finding out what all those additional auxiliary costs are. And then you have serverless and no-ops. Although bundle serverless and no-ops together, they are two different concepts. So serverless being you don't really manage the resources of what you're deploying, but you might be running the operations. For example, you might say how it's going to scale or deploying a container. No-ops is you really don't worry about anything. You just deploy a function, for example, and full scale and manageability and networking is managed for you. But we're bundling them in the same kind of package because they have the same convenience factor and around the same cost model as well. So serverless and no-ops, mostly we're talking about Azure Functions, AWS Lambda, which is functions as a service, which is maybe a layer above, but we can stick them in serverless and no-ops for this discussion. So if we look at that top to bottom, it's cost effectively cheapest all the way down to the most expensive. Even if you can deploy some Azure Functions, for example, now that don't cost you anything because there's an entry level margin there. They're still costly when you actually start getting the bills. So we look at the convenience model. So under subscribing is the fact that you have a certain amount of compute that you don't utilize. You don't get rewarded for that with most cloud providers, US providers particularly. You don't even know how you're under subscribing. So they have data centers not doing anything or containers not being fully utilized. You get no benefits from that. Convenience is overcharged. So the fact that you have a convenient model that you can deploy a function quite easily and scale your application massively and allow your developer teams not to really think about infrastructure, you are paying a huge premium on that, typically when the bills do start coming. And then it's cheap and free a lot of the time when you start off. So you get either, again, the grant funding, the tokens, whatever you get from your provider that gets you onto their platform, but that's about vendor lock-in. If you build something with Azure Functions, for example, it's very hard to move that to a different provider, even though essentially you're talking maybe about a C# stack or a Node.js stack. You still have a lock-in there where the rest of the framework around that is built on that provider. So you will pay that bill eventually. There is a reason for them doing that. And then most convenient services are undersubscribed. So the calculation we got towards the beginning of this year is around 83% of services are undersubscribed. That's a huge amount that you're paying on top of because you don't realize what you're undersubscribing here. And then egress is often charged at a premium. So most, if European providers charge you an egress, which a lot don't, and egress is the outgoing traffic, it's often charged at a premium. So let's take a European provider might charge for 10 gigabytes at a certain amount. A US provider will charge 100 gigabytes at that, charge for the same amount for 100 gigabytes. Essentially, it's a 10 times multiplier for the ones that charge, but you can get a lot of free egress in Europe that you can't get in the US as well. That model's going to change because the weight's being shifted right now. There's too many providers providing free egress, so the US model has to shift a little bit, but there still is an auxiliary cost on top. And then pricing is rarely transparent, and that's what I mean by auxiliary. You get your bill on AWS or Azure, and it's a lot more than you expected because you were just looking at the compute and not the rest of the auxiliary charges. So certification as well. A lot of people are certified as AWS, Azure, Google Cloud, and it creates a complicated model because once you get an architect that has that certification, they tend to be locked into that mode of thinking with the architecture, which limits your organization as well in terms of the flexibility of the solutions you can provide. And even though all three cloud providers, what we talk about there, AWS, Amazon, and GCP, are essentially built on the same kind of concepts in terms of cloud provisioning. They all have Kubernetes, for example. They all have software as a service. They all have functions as a service. They all have serverless. They are effectively rebranding them in different ways. And those models are overly complex in order to make certification valuable, in order to make certificates valuable for selling a consultancy services, and then obviously providing you with vendor lock-in because you've spent so many hours training yourself into that product landscape for each provider that why would you look elsewhere? So you have that kind of complexity issue with a certificate model. So they are vendor lock-in tools. Most concepts are transferable. I can show you blueprints on those three main providers and how they overlap most of the time. There are some nuances there. And then most services are built on open source. So it doesn't matter which company you go with, their underlying stack typically is built on open source. I always recommend learn about the open source tooling rather than the specific implementation of the cloud provider first. You can extend to learn about their specific implementation of that, but the open source tooling will get you a lot more value for your development teams and your engineering teams. So how does that compare to the sovereign cost? I'm going to try and move a little bit faster through the slide so we get to some of the nitty-gritty of making this transition, but the pricing is often more transparent. You will see the pure computational cost with no additional extras. You understand exactly what you're paying for. The bill is predictable at the end of the month. The auxiliary services like networking policies are not hidden, so if you are adding a network that costs money, you will see it very clearly straight away most of the time. They don't copy that model of hiding them. Egress fees are more agreeable to non-existent. Again, a lot of the time you can get 100 gig egress without paying anything. And then you have what we calculated last year was over the last 2 years actually now is 46% reduction of average cost by going to a European provider, specifically European provider. And that's because it's a lot more agreeable with the way they're building their data centers and the fact they're not masking those costs. And then we'll talk about green ops a little bit in a while, but 60% reduction of average cost by going green means that by looking at how to make your cloud infrastructure more sustainable, you typically will reduce your cloud infrastructure by 67%. So it's a very cost-effective way, even if you don't really care about sustainability, it's a great way of actually measuring your resource usage. So it's worth looking at the green ops model. And again, that was between 2023 and this year on the projects that I've worked on. These are large scale. So let's get into the interesting blueprints. So the traditional view of what a serverless is, and again, this is really simplistic, but it applies pretty much to every serverless idea. You often have a CDN, or I'll cover edge networks in a little bit, but because I think CDNs are a little bit old school in terms of the way we think about edge networking. Edge networks create a more broad understanding, but you have a CDN. The CDN might be providing assets, but it's also often the gateway into your applications. The CDN provides the caching capabilities and everything else and sits in front of your functions. So you could have 1,000 functions in your organization. It might not be functions, it could be containers as well, but I really want to talk about functions here because they're the most convenient solution and you can really scale effortlessly using either zero functions or AWS Lambda or whatever else you might be using. That they are very tempting and very cost-effective way to get started with a solution. So I want to cover those as a serverless model. And then typically you have a database. It might be a key value store, it might be a graph database, but you have a database sitting behind your functions. Again, it's not a one-to-one relationship. It could be 1,000 functions and 2 databases, but that model does exist. And then often, and I believe you should, have an event queue. So an event queue manages that. It could be Event Grid on Azure. It could be a Kafka event queue. It could be Redis, but you have an event queue there. And that event queue is an enabler to making transitions later. So I do recommend building with an event-driven architecture most of the time. And then you have your egress, and this is where the costs come in for the egress model. So that's the traditional model. So how does sovereign differ when we're building sovereignty? Because a lot of the time people don't want to move because they can just deploy a function. Why would I go to something where I have to do a little bit more work, or maybe a lot more work? It's a CapEx, OpEx kind of calculation here. So you have a CDN again with the sovereign view as serverless, but now we have an edge compute. And why this is a sovereign idea, it isn't really, but why we talk about it as a sovereign idea is because it's an enabler to moving towards sovereignty. where the CDN is a nice concept. Edge compute is essentially a model enabled by the CDN. It's enabled by being able to use edge networks all over the world to run actual compute rather than just providing assets and caching. And there are a couple of major providers such as Akamai, Fastly, who else? Well, let's go Akamai and Fastly that are US-based, but will be an enabler towards sovereignty. And then there are some European CDNs that are providing edge compute now, such as Bunny.net as well. So I always recommend now moving towards edge compute for a lot of your policy making and base compute. And then you have your host. Your host could be anything. It could be a Deno instance, for example, Deno instance, or it could be a WebAssembly host. But however you build your host, it's a host for running computation, essentially, that restricts all of the complexity of the operational model. Then you have your database again, so like-for-like model effectively. And then you have your event queue, which again is an enabler for this. So the model is somewhat similar. The difference here that is hard to kind of comprehend in complexity is the fact that your host could be a VPC with a runtime running on it. It can be a lot more complicated than just having an ability to deploy a function. It becomes essentially a self-service model. And then you have your egress as well. And this becomes more apparent in the next stage as well. So if we look at the comparison here, we have an enabler here with WebAssembly. So WebAssembly is a fairly emerging technology in some regards. We're almost at major version 1 with WebAssembly, but WebAssembly is actually powering massive scale systems already right now. I have clients at the moment that are huge retail organizations globally, and they use WebAssembly in the model I'm going to show you to reduce cost and allow transformation to happen more cost effectively. And they use it as a primary development tool now. So we're moving away from the idea of a specific language for functions, and we're also moving away from the idea of containers. So containers are they're not obsolete, but they're certainly limited in their benefits now when we compare it to WebAssembly. So you can use something like Bunny.net, as, again, that's a CDN with compute capability, or build your own VPS and run WebAssembly on that, or whatever serverless runtime you want to. Tooling is mature for WebAssembly. So we have Fermi Spin and Wasm Cloud as the two main tools that I use. And they both offer very similar things, so you don't need to choose one or the other ones or understand both. If you look at Azure, they have Fermi Spin built in. If you look at Google Cloud now as well, they've just announced some work they're doing in that space. And even if you look at Akamai as an edge compute provider and CDN, they have Fermi Spin built in. And the benefit of that, apart from the computational capability, is Fermi Spin also is a very powerful toolkit allowing you to do polyglot development that's really performant and replace your containers. There are limitations which I can cover as well, but not in this particular talk. But those limitations are going to disappear as well over time as the system interface with WebAssembly keeps developing. And then compute in WebAssembly is sandboxed. So it's 50 times more efficient than containers, or over 50 times more efficient than containers. This is a proven metric, and it's proven in both Azure and Google Cloud who use this. Startup time is less than 1 millisecond compared to minutes with containers. So if you think about your cold start times with a cluster, for example, you're looking at less than 1 millisecond, allowing you to build a fast model, functions as a service or serverless model, because you're not having to think about containers or Kubernetes. You're just deploying different WebAssembly modules into your clusters. And this is all measured on GCP. Where it achieves 7 times faster pod scheduling and execution than traditional containers. And execution speed is 50 times faster than traditional serverless cloud technologies, and 50 times app density. That means you can run 50 times more compute on a cluster on Google Cloud with WebAssembly than you could with traditional containers. So that means cost effectively, that's a measurement you're looking at in terms of how much compute and execution you're paying for every month. And again, you also, with this model, can start reducing that amount of undersubscription that you're experiencing. So containers. The traditional view of containers at the moment is you have a container, event queue, and database. Again, we don't need to go into the specifics of that, and you have your egress. Then you have a proxy and a load balancer that you don't think about when you look at the traditional view most of the time. You deploy a container, and unless you're managing your own virtual private service, you don't have a load balancer and proxy to contend with, because they take a lot of that weight from you. So you're just looking at deploying a container, and you can do that really effectively with something like Google Cloud Run and without thinking about anything. So when we look at the sovereign view of that, you have your container again, you have your event queue in your database, and you have your egress. But now you have to think about your proxy. A lot of sovereign cloud providers do not provide you with automatic proxy capabilities. So this is something that you have to start thinking about very early on. And then you have your edge compute instead of your CDN, because you have much more capability there. But this differs in complexity quite a lot, because once you've built this, you also need to consider the computation that you're running in terms of the virtual private compute. You need a virtual PC, or you need something else. Most of the time, the runtime is not available for you with European cloud providers to run your own, or if you want the flexibility with having a US and European and maybe Chinese provider, you need a model that is transferable across all three, which means you need to think about the virtual private compute, because those concepts do not transfer technically as well, without managing the actual operating system underlying that as well. And I'm going to talk about how to make this simpler technically in a moment with your product teams as well. So if you look at the blueprint comparison, lower down, the more cost-effective and similar model. So we look at serverless no ops. It's not cost-effective, but it's really, really simple. It's also not similar to the sovereign model, because each serverless provider, when you're looking at no ops and serverless, have their own unique model. They don't often use open tooling. Then you have your managed containers, your unmanaged containers, like mostly talking about Kubernetes here, your virtual private compute, and your bare metal. As you get lower down, you suddenly have a more open ecosystem where you're using open source tooling predominantly and common concepts and not a proprietary set of tools. So it pays to go a little bit further down when you have the capability to do the investment into building that infrastructure yourself. But that doesn't mean that when you go from serverless down, that suddenly you have a lot more complexity. Managed containers, for example, are really, really easy to do if you're using the right tooling, which I'll go over in a moment. And then cluster management. I'm not going to go over an architecture for this, because Kubernetes is universally the same. There are different tools with each provider, but fundamentally, it's pretty much identical. Some of them come with pre-built services within them, but you can swap those out most of the time. Auto-scaling is very powerful. With each provider, you typically have auto-scaling. If you go with a sovereign solution, you might need to implement your own auto-scaling. Kata is a great solution for that, and your auto-scaling can be metric-based or it can be event-based. It doesn't really matter, and you can scale horizontally and vertically. You have all the same capabilities that you have with a provider. You just might be a little bit more conscientious of how you're doing that. But you don't need to build your own management layer in Kubernetes, because most sovereign providers have a managed Kubernetes offering that makes it really, really simple. You just need to decide which containers you're deploying and how they work together. Load balancing is available in most places. They're pluggable. So you typically have a ready-made Kubernetes offering with load balancing built in. If you need to build your own, which on some providers you do, it's very rare. It's not that hard to do that anymore. And I recommend using the edge compute to do that. Clusters can be hybrid, so you can have traditional and sovereign at the same time, meaning you can build into the US provider and build into European provider and use one management layer over the top to make the transition a little bit easier. You can even do on-premise and cloud at the same time, which I've done for a large Swedish client before. And that's quite a cost-effective way of making gradual migrations towards sovereignty or even on-premise data centers, which a lot of companies seem to be doing at the moment. And then replacing containers with WebAssembly for flexibility and efficiencies. I highly recommend looking at that space. Unless there's a reason to use a container, don't use it. It's essentially a virtual operating system. It has so much underneath it that is not required in most cases. So consider building in WebAssembly, which is a polyglot technology. So you can typically use the technology your teams already use. So the transformation, how do you make this switch? So the principles of transformation are fairly straightforward. Proxy all traffic, including internal. And the reason to proxy internal traffic is because you can change the rules and pull in and pull out modules as you go, as you build your solution. So if one of your functions is calling another function, get them to call your proxy before they go to the other function. Route DNS traffic, build networking that's effective, and then you can build a policy management system and authentication system around that. Use edge-based computation where you can. Again, I can recommend providers or architecture to go with that, but find an edge-based provider like Akamai or like Fastly and build that computation there to allow you to have the flexibility to swap out the things behind the edge more effectively. And those are global. Fastly, for example, is I think it's 107 edge points now around the world. So that's fairly local. And use zero trust architecture. If you don't know zero trust architecture, looking up, but we're essentially talking about removing the idea of authentication and authorization from your services and building it into a sidecar model or an ambassador model, essentially. I'll show you an architecture for this in a moment. Use small teams, independently run, give them the freedom to pick the tech stack that works for them, and then they will explore other potential tooling. If you say as an organization wide, we are Microsoft Azure house and that's all we're using, you will limit your capability to try other things in a very safe manner. If you have a small team of maybe 4 or 5 engineers that suddenly try a new provider, that is a really risk-averse way of testing out something without migrating your entire organization to a different model. And then use group governance and communication. So although you have small teams, they communicate with each other effectively of what they're trying and what they're doing. It's not didactic. They don't say this is the way you have to do it, but they have a flexible model that way. And then transformation never ends. What I mean by this is some organizations have a 10-year roadmap to make this transition. These are huge global organizations that are putting millions, tens of millions into this model. But they're doing it in a way where they're saying, you know what, in 5 years, this model may be obsolete. But because we're doing it piece by piece, there's no risk to doing this. In 5 years, we will have a different approach, but everything we've moved is still effective. You have to kind of build it in a throwaway model, but in a modular way as well. And the organization I'm talking about has a monolithic solution. So if you're building monolithic solutions, this doesn't mean it's not for you. It just requires you to think architecturally a little bit different in terms of your edge compute. So let's look at the monolithic solution, for example. This is really simplistic, but it shows how this is built. So you have, for example, your app service and database, which we're all very familiar with. This could be one code base, it could be multiple, it could be 100 apps, 1,000 services, and 3 databases. The model is very flexible. Then you have your auth policies. So you have your OAuth 2, for example, interface, or whatever interface you have there. You have your policy management. It's all on the front end, managing all the traffic to your app services and database. It could be built into these solutions as well. The model for transformation is to move that away, make it a sidecar, then build against the edge compute. So put the edge compute in front of all of your services and make sure the routing and rule-based system goes through the edge compute first, and the edge compute will look up the auth and policies as a sidecar. This is a common model called a sidecar and using Kubernetes everywhere, but not everybody does this. A lot of people use the simplistic model I showed previously. And then if you want to build a new service, the edge compute routes to that service. And now let's take an example of maybe you want to build a service where all people in France now get routed to a slightly different set of ruling, a different product set, maybe a different database. So you build a service that handles this. And you build this to allow a transition to a new provider or new infrastructure. The edge compute manages that. So as far as the end consumer is concerned, it's the same. As far as the rest of your development teams are concerned, it's the same. But what's actually happening is some really clever under the hood masking in front of all of your new services to make things look a little bit different. This is how the larger companies, such as Adobe, for example, are kind of breaking down the very complicated infrastructure to move to more agile technology. And you could do it with applications, databases, everything else. So essentially, you're shifting the traffic a little bit and making it a little bit more simplistic in order to take things out and replace things. So what's the strategy for going against this model? So looking at the future-proofing of your cloud strategy, highly recommend using edge computation to retain versatility. And this means predominantly using WebAssembly as your edge compute to allow you to build it programmatic rule sets. And build services lower down the stack. So start looking at Kubernetes, start looking at the layers where you have more control. You don't need to do that overnight. It can be iterative, but start thinking about doing a little bit more capital expenditure to get a massive OpEx benefit. And then use open source. Look at the cloud native compute foundations landscape. The open source landscape is what all cloud providers are built on. If you understand the open source landscape, then you don't need to worry about the cloud provider you're with because they will provide a lot of that tooling capability, and whatever you build will be migratable. I'll talk about that in a moment. And then apply infrastructure as code principles. Most people use Terraform, and make sure you're using something. I use Pulumi. It doesn't really matter what you use, but make sure you're building things programmatically so you can shift out the components programmatically as well and manage that effectively. And then refrain from going all in on one provider. That doesn't mean you don't use one provider. It means you don't commit to that provider. You build in a way that allows you to be flexible. And then enable teams to choose their own tooling, as I mentioned before. It really gives you a massive benefit. And then apply green ops instead of FinOps. FinOps is about financially modeling your operations and saying, okay, looking at our metrics, we need to reduce the cost on computation or storage or whatever. Green ops allows you to say, we need to reduce the carbon impact or the water usage in this, and looking at these calculations, this would mean a shift to this provider. We've seen a 47% cost improvement in 2 years in just people doing green ops over when they were applying FinOps on its own. So I do think it's a better model. Again, even if you don't care about sustainability, it's a better model for cost-effective development. Okay, so now I think we have some time for some questions. I just want to point out that a lot of these providers have a capability to support OpenStack as well. So OpenStack allows you to provide kind of a programmatic way of deploying containers and clusters and everything else. If you want to start edging towards this idea of building in this way, build with OpenStack on every provider, and with an open source tooling, it will allow you to make this transition easier because you just swap out the provider endpoints rather than re-architecting everything. It's a little bit better.
Okay. Thank you so much. And I can see that a lot of people have been listening in, and I have one question for you as for now. So this is it. There are modules for Terraform for OpenStack. There are also a cross-plane provider, which is great. Thus you can pick any Swedish provider. I'm not sure if this is a question or
oh, no, but it's a good comment. I mean, yeah, cross-plane is a good way of making this transition, definitely. And if you're talking about Swedish providers, then you have that capability. This is the reason I use Pulumi as well. The tool of choice for infrastructure as code is very flexible and open. But this is the reason I promote using infrastructure as code, is to have that flexibility of just changing bits out in a lot more modular fashion. Typically with US cloud providers, you would go into a dashboard and click things when you're first starting out, which I never recommend that model, because then you have to reverse engineer what you've done into code later to figure out how to rebuild that infrastructure. It's better to use these tools and then give you that flexibility later on.
Yeah, thank you. I move on to Mats, who has a question. Are there any providers you can recommend? I work with a few, and there's always been a lot of problems. Technicians are unfamiliar with the tools, and the support is often really bad. It's very difficult to find good providers in Sweden or the rest of Europe.
Yeah, that's very true. This is why it's a difficult space to operate in. I think there are providers I recommend. I would say at the moment, my biggest recommendation is Leaf Cloud. Their landscape is really simplistic. They don't have a lot of tooling, but they have everything you need. You just might need to do a little bit more work. They're reliable. They provide you with technical support really, really well. They will give you an individual that you can speak to who really knows their stuff. If there is an issue, which I've never experienced, but they tend to fix issues permanently on the infrastructure when one comes up. So they kind of look at the issue arising and then change something systematically across the entire org to make sure it doesn't happen again. And the Leaf Cloud are based on sustainability. So they're building a cloud provisioning service in the Netherlands, which is based on the idea that all the energy for the data centers is sustainably sourced, and then all the heat transfer coming out powers things like swimming pools and other excess heated water solutions. So they make sure that even the egress of the energy is used effectively, which is a nice bonus. If you don't care about that, that's fine, but it's still the fact that they are cost effective is a great winner. To go with someone like Leaf Cloud, you need to use OpenStack effectively. You can do other things, but OpenStack is the best solution going forward. And again, I use that with Pulumi. Other providers, I would say, if you want to go with really simplistic edge solutions, then look at bunny.net. They will provide you with a way of deploying containers, deploying edge compute, and doing your CDN. And they're based in, I think, Slovenia or Slovakia. I can't remember exactly which one it is, but they're a really interesting company right now in terms of building that. I have worked with Civo as well, who are based in the UK. Civo have been pretty good. I've not had major issues with them, but I kind of moved to leave cloud because I felt like the ability to communicate and get things done effectively was better. And I've used Hetzner, which have an awful reputation for customer support. I think everybody knows that, but I haven't had any issues with them technically. So I've used them a few times. I wouldn't recommend them. I think there's a lot more work you have to do to get them to work effectively, but they are pretty stable.
Great. I'll take the next one. What do you think about Amazon moving away from cloud back to monolith and saving 90% budget? Is monolith the future?
So no is the answer to that. So I think it was 2 or 3 years before they moved everything away from monolith and to serverless Swift, I think it was, and on Amazon Prime to run their streaming service. And they were talking about the same thing, how moving from monolith to modular allowed them to save money and deliver more effectively for the Prime service. So the fact 2 years later and they're now saying the same, going the opposite, just shows the fact that it's not really a monolith versus modular argument. It's a what fits your particular product team and development is effective. I personally don't subscribe to either. I will start a project monolithically because that's the quickest way to get into production. Then over time, I will start breaking things down and making it more modular. What I will say is, I know a Swedish company who's global, and they built a monolithic stack, and currently they have that monolithic stack running all over the world. Now they're breaking it down because they realized that for the last maybe decade, it's been more of a burden to manage that, and it restricts them on doing a transformation model later. So they're investing a lot of money in making that transition. So I would say it's a lot to do with scale and on size and what you're effectively doing with your product development teams. But I would say don't get into an argument with your product development teams over that discussion. It's the same as arguing which programming language is best. It's a redundant argument most of the time, so it's not worth having.
Thank you. And let's see, could you provide a real-life example of a WebAssembly project and explain how it was more efficient or cost-effective compared to traditional host or containers approach?
Yeah, so I can give you tens, in fact, because over 2 years I've been focused in this space. So Adobe is a good example. They've moved from containers to WebAssembly and saved millions in operational costs. And they're doing that on Azure at the moment, and Microsoft's supporting them in that transition. Microsoft's official viewpoint, at least from the conversations I've had with the AKS team, is move away from containers because they're not efficient anymore. That doesn't mean don't use containers altogether, but use them when they make sense. Otherwise, default to not using them. So they have on AKS, they have the ability to run WebAssembly now instead. And the cost capabilities because of the under subscription is massive. Then again, I mentioned the Swedish company, they're doing the same thing. They're building effectively, I can't mention who it is, but they're building, there's not many global Swedish companies, so you can make some guesses. They're effectively using WebAssembly on the edge compute to re-architect everything behind, and they're saving a lot of money in doing that transformation model. I've used it predominantly in the last 2 years, although I've used it on the cloud. I've used it in automotive, actually. I've run WebAssembly workloads in vehicles, and I've used this to load balance artificial intelligence workloads. So rather than using AWS to do AI training, I've done AI training in vehicles locally using WebAssembly in a safe, containerized manner where I don't need a full container. So I can use the GPU and the CPU in the vehicle without draining the battery or oversubscribing to the resources in a vehicle when it has other things to do. Which is a very, very restrained and constrained environment to try and operate in. Otherwise, well, I think banking, I've used it in the last 12 months. I built an entire software development kit for a cloud storage company, which everybody probably knows, and I can't mention the name of, that do a Dropbox-like solution, but it's not Dropbox. And they built their SDK and their cloud tooling in WebAssembly. And that was effectively to allow developers to extend more in a self-service model and allow third-party developers to deploy. And then finally, I would say Shopify is a great example. Actually, Shopify have everything running in WebAssembly on the, not everything, but everything new that they're building is fundamentally in WebAssembly. And you can look up their public discussion in this as well. I can find articles later as well if somebody wants to reach out to me, and I'll find some use cases to share.
Great. I'll move on. Can you mention a success case Can you mention a success case company that shifted to sovereign cloud and key challenges they faced during the transformation?
There's definitely some successful companies. I think most of the companies I've seen doing it do a hybrid approach. So they move some to the sovereign cloud and they leave some in the US. And that's not because the US does things a little bit better at the moment. They do. I can't argue against that. But they do it because there's no point you moving everything to Europe unless if you have traffic in the US still. It's a nonsense model, but it's the same model that companies who are trying to deliver to China at the moment have to use a Chinese operator. As long as you abstract the model backwards enough to think about containers and orchestration and build along those ideas, you can essentially build the same service and deploy into Chinese solutions like Alibaba or Huawei into the US and into Europe without really thinking about the region you're going into. You just have to kind of understand the provider differences. So yes, I have seen some. I think mostly the industry I've seen this happening is retail and finance. Again, I can't mention clients in this case, but the finance are doing it because of regulatory requirements. And then a non-profit in Sweden, actually, which again is probably guessable, but a non-profit that works on the internet infrastructure, they moved to on-premise away from AWS. So they went the full route all the way to building their own servers and data center. And that wasn't just about cost-effective management, although it was more cost-effective, but it was also the fact that it was legally required that they could not use a US provider anymore, because they were building national infrastructure in Sweden. There are quite a few use cases like that as well. And then I think there's a retailer in the Nordics as well, in terms of a grocery retailer that I know has moved to European data centers. And this is why Azure, Amazon, I think Google Cloud as well, are all building sovereign data centers in Europe, meaning they're building data centers that aren't managed by them. They're managed by a European company in order to try and start taking this market share back a little bit. But that only solves the judicial issues, not the rest of it.
Great. Do we have time for one more question? The last one?
I have time.
You have time. I will shorten it a bit. Can you expand on where CDNs and edge computing can fit into my architecture and what the benefits are?
Yeah, so if you're not using a CDN at the moment, then I recommend it anyway. So CDN is essentially your front cache for your assets to reduce the amount of ingress load you have and egress load you have. So using CDNs is highly recommended for that basis. Most of the time you're using a cloud provider, they have a CDN built in that you just need to switch on. The edge compute is essentially the new model that leverages those networks. So the leading networks are, I remember the third one. So it's Cloudflare, Akamai, and Fastly are the leading edge compute providers, mostly in the West. And they've been building just things for CDNs and routing and things like that for a long, long time. And a lot of people use one of those providers. If you're using Microsoft, you're typically using Akamai, for example, as your edge compute provider, even if you don't know it. And because they've had this capability where they've built this service infrastructure that's over 100 data centers globally, give or take, and it's all hyperlocal and it's all distributed, they realize that they can run compute now. So a lot of them are allowing you to deploy WebAssembly functions and services onto that edge compute and not use a cloud provider at all, but actually use a CDN compute. And that makes it really effective. You can actually, within minutes, write a program in the language of your choice, compile to WebAssembly and deploy to an edge provider. And the deployment will take a couple of seconds, and then it will be across 107 data centers. And most of the time, you're not paying for that unless it hits over a certain amount of traffic. So if you're have a high traffic system, then you start paying for that. But you can get away with low traffic solutions, prototypes, MVPs, even a small product without paying a bill on that, which means you're not using a cloud provider at all. They have their own key value stores. They have their own object stores. So you have all the capabilities you need to do that. So when you're talking about maybe where to fit in that into the infrastructure, it's your proxy and ingress. That's regardless of what you do with the CDN, it's your proxy and ingress when you're using the edge compute. And then you can just use the routing traffic and the authentication model on that. But then you can actually build some of your services in those edge networks as well and start reducing the amount of work you're doing on cloud providers, and even not think about containerization anymore or deploying databases. It's a little bit more simple, that model as well. And then when you hit the limitations, which there are limitations, you can just then deploy the container or the other module or the service elsewhere then, and not have to think about that in the very beginning. I know a lot of people use Cloudflare very much in this model and build almost everything on Cloudflare, which shows how this model works.
Great. Thank you so much. I think that was the last one, and I'm really happy that we were able to listen into this presentation from you, and I'm sure everyone is glad to be able to ask their questions as well. And so that's all for today, and hope you all have a nice lunch, and thank you again, PJ, for your presentation.
Thank you.